All right, boys and girls, so today we're going to move into section 7.6, which is about the natural logarithm. This is a new type of logarithm here in which we have the base of the number e. All right, so to review, e is approximately 2.718. It's named after Euler, Leonard Euler, the mathematician. We talked about it with the continuous interest formula, where the amount is equal to the principal times e raised to the rate times time. And then we also need to remember those properties of logarithms that we've talked about. Okay, so what is a natural logarithm? Well, it is a logarithm with a base of e. Okay, so it's written in expanded form as log base e of x, but as I've told you several times, mathematicians are notoriously lazy, and we like to write as little as possible. So it's actually ln of x. Now, it's called a natural logarithm, so you might be thinking NL. Why is it ln? Well, of course, it was French, and so it's log de natural. That's how it would be pronounced, and that's why we write it as ln instead of nl. But regardless, ln of x means log base e of x. So if we convert it to an exponential equation, again, we need to know that b to the y is equal to x is the exponential form for log base b of x is equal to y. Okay, we should hopefully have that memorized by now. So when we convert this, again, we need to understand that the base is e. So we would rewrite this as e to the third power is equal to x. Well, since e is a irrational number, it's not going to come out evenly. So we would go ahead and hit second and then our natural log button. Sorry. Second and then our natural log button. That gives us the e to the blank power. Well, e to the third power is approximately 20.086. So that is what x is going to equal here. Okay, again, round to 3 decimal places. Okay. When we are simplifying using those properties of exponent or properties of logarithms, okay, we need to remember that when we have a number in front of a logarithm, that is going to become an exponent to the part. Okay, so the first thing that we're going to do here is rewrite this as the natural log of 15 squared minus the natural log of 75. Well, 15 squared is 225, so we actually have the natural log of 225 minus the natural log of 75. Now, when we are subtracting two logarithms with the same base, and that's what these have, they're both natural logs, so they have the same base, we divide their parts. So we can rewrite this as a single logarithm of 225 over 75. When we do that math, you get 3. So this is just the natural log of 3. And that is our single logarithm right there. Okay, the same properties for normal logs work for natural logs as well. So I have two problems here. Go ahead and use those properties of logarithms to solve them, or simplify them, I should say. And then I'll give you a chance, pause the video here to do that, and then I will show you the answer. Okay, so hopefully you ended up with these two as your answer. The steps are shown, and that should do it for today.